Hi everyone, welcome back. This session will focus on vectors, which is a fundamental concept in physics, essential for understanding how forces and motion operate in the real world. These ideas will be used throughout the A-level physics course, so are really important. We will start with a review of Pythagoras Theorem and trigonometry, which you must understand for all of vector analysis. The tutorial will then look at defining vectors and demonstrate how to calculate resultant forces in 2 dimensions. Finally, we explore the concept of equilibrium and at the conditions for which forces are balanced. So lots of calculations, lots of examples. Let's get to work. Right, the first thing you must know is Pythagoras Theorem. You will have done this at GCSE and possibly earlier in school, but it is so important we are going to go through it again. So this only works for a right angled triangle. We have 3 sides, A and B, doesn't matter which way around they are. C is the hypotenuse in this case. So C squared is equal to A squared plus B squared. Basically, the sum of the squares of the 2 sides is equal to the square of the hypotenuse. So if we wanted to find one of the other sides, then we need to rearrange this formula so it looks a little bit different. So generally speaking, students are very confident with this, but we've got to be careful to make sure we can rearrange. So a couple of worked examples. So this will be a nice easy one here to find the value of the hypotenuse. So all we need to do here is to square 10 and square 8, add the 2 together and then find the square root, and we get the answer of 12.8. Now that should make sense. So the hypotenuse is the largest of the 3 sides, so 12.8 is a bit bigger than 10. Sounds about right. Okay, another example would be over here where we're given the hypotenuse is 11 and we're trying to find, it says x and y, so yeah, x and z I think that should be. We're trying to find z, so here we have to do the calculation as shown. 11 squared take away 7 squared and then square root. And if you do that on your calculator, you should get 8.5. Now, if you did what a lot of students do, 11 squared plus 7 squared, you would get a number larger than 11, which must be incorrect. So the hypotenuse must be the largest of the 3 sides. So always apply a bit of a common sense check to that. Right, the other absolutely essential mathematics skill is trigonometry. So basic trigonometry, SOHCAHTOA. So you must have seen this before. So most students know the mnemonic SOHCAHTOA. You should know what SOHCAHTOA actually means. So SOH, so the sine of the angle is opposite divided by hypotenuse. The cos of the angle is adjacent divided by hypotenuse. And the tan of the angle is the opposite over the adjacent. So we could write this diagrammatically or draw this diagrammatically. So we've got the adjacent is the side next to the angle that we're talking about, in this case theta. O is the opposite on the opposite side, and H is always the hypotenuse. So worked example, use trig to calculate the value of x. So the first thing we need to do is think, well, which sides have we got? We've got the opposite, which is x, opposite to the angle, and the hypotenuse. So it's going to be sine, and then we could write out sine of 30 is the opposite, which is x, divided by 10. So we end up with this expression here. So that's really important that we write the correct expression with SOHCAHTOA. Once we've got that, well, we're trying to find x, so we can rearrange this expression. X is equal to 10 multiplied by sine 30, which will give us the answer 5. And then always apply the common sense check. Does that make sense? If we got a number bigger than 10, that would have to be incorrect. 30 degrees sounds about right. So always apply a common sense check. So 2 more, we've got this one here, so we've got 60 and 4 and x. In this case, we are given the angle and we're given the adjacent and we don't know the hypotenuse. So adjacent and hypotenuse, it's going to be a cosine, so it'll be this one here. So it's always worthwhile writing out that formula. So cos of the angle, cos of 60, is equal to the adjacent, 4 divided by the unknown x. Now be careful here, a common mistake is for students to rearrange this as x equals 4 multiplied by cos 60. That will give you a number smaller than 4, which must be incorrect. So we're actually swapping over the x and the cos 60. So x is equal to 4 divided by cos 60. Cos 60 is less than 1, so we get an answer greater than 4, which makes sense because the hypotenuse must be the largest of the three. We can also use SOHCAHTOA to find an unknown angle. So once again, we don't know theta, so we need to identify which of the two sides are we interested in. 8 is the opposite, and 12 is the hypotenuse. So once again here, it's going to be SOH, S-O-H. Sine is equal to opposite over hypotenuse. So we can write that to start with. So the sine of the angle is the opposite, 8 divided by the hypotenuse. And we work that out on a calculator. So 8 divided by 12, press equals, and then find the inverse sine or second function sine of that value. And you should get 41.8. So make sure you are on degrees on your calculator, not in radians. That's a very common mistake. And once again, apply the common sense check. So does it sound about right? So if this was 8 and this was 12, 41.8 sounds about right. Okay, there are also two other rules which they probably won't come up. They tend not to be on physics A-level specification, so they're not essential, but an awareness of them may be useful. So the sine rule and the cosine rule. Most of the triangles we're looking at physics A-level will be right-angled triangles, but there may be times perhaps when these rules are useful. So I won't go through them now because they're not actually on the specification, but an awareness of them could be useful in some situations. Right, let's get stuck into vectors. So vectors you will know from GCSE, hopefully. We've got scalars and vectors. So a scalar has magnitude only, by which we mean it's only got a size. So mass, distance and speed, there is no direction for these quantities. A vector has got a magnitude and a direction. So for example, a displacement, velocity, force, acceleration. So very often these things are interchangeable. So we might talk about a car having a speed of 20 meters per second, or indeed a velocity of 20 meters per second. But if we're being correct, then if we're talking about velocity, we need to talk about the direction. So it might be 20 meters per second heading north. Similarly with distance and displacement, very often we use these terms interchangeably, and they may in fact be the same value, but sometimes they're totally different. So we might have a distance of 5 meters, but we might have a displacement of 5 meters towards the left or vertically upwards or something like that. So magnitude and direction. So a nice way to illustrate the difference between the two, looking at distance and displacement. So if a person walks 4 kilometers east and then 3 kilometers north, then the distance they have walked is 4 plus 3, which is 7. That's fine. However, the displacement will be the direct line here, which is going to be the hypotenuse of the triangle. So we can use Pythagoras to work out this direct line here, this direct root. So 3 squared plus 4 squared square root is 5, and that's a 3, 4, 5 triangle, which you might recognize. And also, if we were saying that's displacement, we'd have to talk about the angle or the bearing, so we need to use a SOHCAHTOA to calculate an unknown angle there. Okay, so very often we look at resultant forces in 2D, in 2 dimensions. Now, we can apply this technique to any vector quantity. So to displacement, as we just did on the previous screen, acceleration, or indeed any other vector, but very often, most of the time, we're looking at resultant forces. And this would be a very typical example. So we have an object, in this case a ball. It's got a weight of 8 newtons, that's acting vertically down, and there's a force acting towards the right, caused by the wind, of 6 newtons. What is the resultant force? Now at GCSE and in the dynamics topic, we were just looking at forces in 1 dimension. So it would have been something like 8 minus 6 or 6 plus 8. But in this case, in 2 dimensions, that makes no sense at all because they're not going in the same direction. So this is the method. This is our general method. So we draw an arrow to represent the 6 newtons. Okay, we've got that one already. At the tip of the arrow, we add on our other quantity, our other force, our 8 newtons. And then we join these two up from the start of the first arrow to the end of the second arrow. So what we have here is basic vector addition. 6 plus 8 takes us to this point. Another way of getting from here to here, the more direct route, is the resultant. That's the hypotenuse of a right-angled triangle. And then we can use Pythagoras and trigonometry as we have done previously. Now, a couple of things. There are 2 correct triangles and there are incorrect triangles. So what I did here is I did the 6 plus the 8. Also, absolutely fine will be to start off with the 8 and then add on the 6. That is perfectly acceptable. So sometimes this causes confusion because there are 2 perfectly correct triangles, which are effectively the mirror image about the hypotenuse. But either of these will give you the correct magnitude and direction. But be careful, very often students draw a triangle which is incorrect. They say we have 8 and 6, and they think, oh, there's a triangle, I'll just connect these 2 together. Now, in terms of Pythagoras, this will be the same value, but the angles will be wrong. But more importantly, it fundamentally doesn't make sense. There is no way that 8 plus 6 could give you a resultant up and to the right or down and to the left. So that doesn't make any sense at all. So if we have a force to the right plus a force acting downwards, we must get a resultant force which is acting downwards to the right. So always check to see if your answer makes sense. So in this case, we have our 6 and 8, the resultant force. Once again, if we're confident with Pythagoras and trigonometry, that should be straightforward to find the resultant. So 6 squared plus 8 squared, square root, that will give us 10, nice and easy. And now, because we know all 3 sides, we could use sine, cos, or tan. I've used tan. So if I want to find this angle here, then opposite divided by adjacent, tan to the minus 1 will give me 53. So let's have a look at a worked example. You might get something like this, which initially looks quite complex, but because I have the 20 acting down and the 6 acting up, I can simplify these 2 just in this vertical direction, 20 minus 6 to give me 14. And then it's very, very similar to what we had previously, because I've got the 14 acting down plus the 8 acting to the left will give me a resultant which acts down and to the left. I can use Pythagoras and trigonometry. Again, I've used tan here to work out the magnitude and the direction. Now, sometimes students ask, well, which angle do they want? Hopefully that will be clear in the question. It will normally say, calculate the angle between the resultant and either the vertical or the horizontal. But hopefully that will be clear in the question. Right, so we're going to look at something called forces in equilibrium. Now, this is very, very similar to what we've just been looking at. It's right angled triangles, it's Pythagoras, and it's trigonometry. But it's also fundamentally different to what we've just been looking at. We were talking about the resultant of 2 forces. Now, in this case, we have equilibrium, which means the forces balance out. So the resultant force is equal to 0. So in this scenario here, we've got a weight acting downwards, we've got a force acting to the right, and we have a string or rope, a spider on a thread, there we go. It's the tension in the thread. Now, this is a really typical question in the exam. The examiners love presenting you with something which is an equilibrium, and you have 3 forces and you have to draw a triangle. So if they're in equilibrium, I can create a triangle by adding all 3 forces together. So again, we've got vector addition. I've got my T, the tension, plus the wind force, plus the weight will take me back to the start. So effectively, these 3 forces have cancelled out. The resultant force is 0. So this is very similar to the previous thing we looked at, but it's also quite different. Previously, we had a resultant force, which was going in the opposite rotational sense to the original 2. But in this case, all 3 forces will be going in the same direction, either clockwise or anti-clockwise, and end up back at the starting point. Once again, we have 2 possible triangles. I've got the T plus the F plus the W. I could have, let me get this right, the T plus the W plus the F. This would be exactly the same as the mirror image, same magnitude, same direction. But as I said, importantly, we do not have a resultant force in this case. The resultant force is 0, which is what we mean by equilibrium. So let's have a look at an example, almost identical to the previous one. So we have a weight, we have 2 ropes, we've got 12 newtons, and we have an unknown horizontal rope. That's what we're trying to find, T. So it says draw a labeled vector triangle. So very often in the exam, that's the first mark. So you need to get your ruler. You don't necessarily need a protractor, so it doesn't need to be to scale, unless that is what it's asking you in the question, but that's a separate skill. And you need to draw a clearly labeled triangle, which is relatively large. Don't do tiny little ones because they're going to be hard for the examiner to read. So the first thing we need to do is to draw our triangle. So I've got my 12 plus my t plus my 5, and I've labeled it. Bearing in mind there's another triangle you could draw. You could do the 12 plus the 5 plus the t, which is absolutely fine. So there are two possible triangles. And once again, we've got a right angle triangle, so we could use Pythagoras. Be careful here, we're trying to find t, which is not the hypotenuse. So the calculation will be 12 squared, take away 5 squared, square root, which gives you 10.9, which is smaller than the hypotenuse, which makes sense. And then once again, we can use sine, cos, or tan to find the angle between t and the horizontal, the 12 and the horizontal, which is going to be this one here. I've used sine, so opposite 5 divided by hypotenuse, 12, sine to the minus 1, 24.6. Right, so that is loads we've covered there. So that's Pythagoras, trigonometry, resultant forces, and forces at equilibrium. So what's next? So the next video in this playlist would be components of forces, which is also really, really important. And this idea of components of vectors will be a skill you need all the way through the Physics A-level course. Or alternatively, if you want some more rigorous lessons, then you could go to payhip.com, grade A physics, and there's loads and loads of information there, practice questions and quizzes and progress tracking. So loads and loads of stuff to keep you busy. Brilliant, well done. I'll see you in the next video. Bye.